The two main requirements to enable vMotion are, of course, shared storage and the VM kernel ports. But beyond that, there are a couple of existing extra requirements that we want to make sure of. The first one says that if we're using raw device maps, RDM disks, the RDM VMDK files, and the LUNs to which it matches has to be accessible on the destination host. This really goes back to the requirement for shared storage. Okay. We also cannot have a virtual machine that has a connection to a virtual device, like a CD, DVD, ISO image, that sort of thing, that is mounted locally at an ESXi host. Okay? So if the ISO image is on a local drive, okay, then the destination host cannot see that local drive. We cannot move the VM. In that case, you either want to unmount the ISO image or put your ISO images on shared storage as well. Now, in vSphere 7, you can use vMotion to migrate a VM with a device that is attached through the remote console. So if on your laptop, for example, you have a USB device that is actually attached to the VM, you can still vMotion that VM. So those were all the requirements for the virtual machine itself. But there are also some requirements for the host. How many vMotions can a host actually execute? That sort of thing. Okay? So we've got to have accessibility to all of the storage. Both the source and the destination hosts have to have accessibility to all the storage that the virtual machines are utilizing. Okay? And we can actually perform 128 concurrent migrations per VMFS or NFS data store. Now that's an interesting statement, because if you think of a vMotion, what are we doing on a data store with vMotion? All we're doing, we have shared storage, we've got a VM on one host, and we're moving it to another host. We didn't touch the data store. Well, we did do one thing on the data store. When the VM was running on the host over here, this host had a lock on those virtual machine files on the data store. And when we moved the VM to another host, we had to switch the locks to the other ESXi host. Now, 128 concurrent migrations, that's a pretty significant number. Okay? So just know that there are a few things that are happening relative to the data stores, even though no files are actually being moved. The next line is interesting as well. It says, if the swap file location on the destination host differs from the swap file location on the source host, the swap file is going to be copied to a new location. All right, we haven't talked about different locations for different virtual machine files. Well, it is true that there is an option that's set up on each ESXi host that says, I want to put the virtual machine swap files on a local device. If you think about that, if I take a local device like a local SSD and I pop it in an ESXi host and my virtual machine is running on that host, and I have overcommitted memory to the point where we have to use that swap file, then that swap file would probably perform better if it were local. Okay, fine. Probably not a great idea to overcommit memory to such an extent that we have to use a swap file, but there we go. And so that's an option. Okay? If that's the case, and you want to move the virtual machine from a host that has a local swap file, we actually have to move the swap file as well. Okay, so be aware of that. You, of course, have to have your virtual machine, your VM kernel port with vMotion enabled. So there's a little checkbox that says vMotion. Okay? And you have to have IP address compatibility, meaning all IPv4 or all IPv6. We cannot do vMotion between a VM kernel port enabled for IPv4 to a VM kernel port enabled for IPv6. Okay, so it's got to be all either IP4 or all IP6. On the network, we need at least 1 gig networking. Okay, vMotion requires a minimum of 250 megabits per second. Okay, so that allows us to do 4 concurrent vMotions on a 1 gig network. If you have 10 gig or higher networking, we limit concurrent vMotions from host to host to 8 concurrent vMotions. Okay, There is some CPU activity going on as well, and the last thing that we want to do is pull CPU from your virtual machines in order to enable vMotion. So we artificially limit it to 8 concurrent vMotions when you have 10 gig networking or better. Okay? One of the things that you can do to improve performance of vMotion is to create 2 VM kernel ports on each host and put that vMotion checkbox there. If you do that and you have 2 separate physical adapters, ESXi will use both of those physical adapters to execute your vMotions. This is great in a home lab if I've got an old server with lots of 1 gig ports, for example, but no 10 gig ports. Use 2 of those 1 gig ports for vMotion, and it will essentially double the speed of your vMotion. We also have to have compatible CPUs. That is, the source CPU and the destination CPU must be compatible with one another. Now that is a big discussion. What does it mean to have compatible CPUs? Well, we'll start by saying that all of the CPUs on the source and the destination must be all either AMD or all Intel. We cannot do a migration between Intel and AMD CPUs. There's enough of a difference there to cause problems. Okay? We also need compatibility between the generations of CPUs within that single vendor. Okay? We'll talk a little bit more of that when we get into this feature called Enhanced vMotion Compatibility, which is the subject of the next lesson. Once we're sure that all of those requirements have been met, we can simply right-click on a virtual machine and select Migrate, choose Migrate Compute Resource Only, and the migration will occur. It will actually run through a series of compatibility checks to make sure that all of those requirements have been met. Okay? In this case, we can show you that when we choose a destination host, like ESXi02 here, it will immediately run that compatibility check to make sure that the vMotion will be successful. And in this case, it won't be because it says there's no vMotion VM kernel port configured on the destination host. So go back, cancel this for the time being, enable the VM kernel port on the destination host, or fix whatever was causing the compatibility check error, and retry your vMotion. Now, a little while back with the release of vSphere 6.5, VMware introduced a feature called encrypted virtual machines. That is, we take all of the data of the virtual machines and we encrypt it. This includes the virtual machine disks and the memory as it's being copied over the vMotion network. Prior to vSphere 6.5, all vMotions were done in the clear. So, when you do have vSphere 6.5 or later hosts, all of your vMotions are now going to be encrypted by the ESXi hosts on the source before they're sent to the destination host. This is the default if both the source and the destination hosts are at least vSphere 6.5. Okay? We'll call this opportunistic encrypted vMotion. If we have the opportunity to do it, we will. If you're trying to migrate between, say, an old 5.5 host and a vSphere 7 host, and the 5.5 host was not capable of doing encrypted vMotion, then of course, you won't be able to do encrypted vMotion. On a per VM setting, you have the option of choosing opportunistic encrypted vMotion, disable encrypted vMotion, or absolutely require encrypted vMotion. If your virtual machines are encrypted, all vMotions will be encrypted. When we come back, we'll have a look at cross vCenter vMotions and long-distance vMotion.